like people may be familiar with this concept. I apologize if this is regurgitating some stuff that you already know, but H3 cells, H3 world tiles, that was developed by Uber. It is a way to subdivide the world at different zoom resolutions, basically into hexagonal cells. So obviously I have stolen this image directly from Uber and embedded it in a markdown tile in Omni. What you're seeing on the right over there is XYZ world tiles. So all of the like traditional maps, like you could go crack open your network panel, load a Google map, load a Mapbox map, any map, and just like monitor the network requests. Most of those are going to be making XYZ world tile requests. So the world at zoom 0 is 1 cell. The world at zoom 1 is 4. So that's what this image is conveying. I have generated just ad hoc SQL as far as you could see at these resolutions. H3 goes 0 to 15, XYZ goes 0 to 20, 22, I think, actually. I confess I asked ChatGPT to just generate me a CSV of the tiles, but they're loosely the right approximation for hexagons and tile counts. So take that with a grain of salt. But I think, a couple things to point out too with tiling, and I talk about this later, is you almost never have to go past Zoom 14 for some of the like vector tile stuff. To your eye, you typically are. Oh, I'm getting an echo. To your eye, you're really not going to notice much difference there. So this is just saying the same thing that was the table format. These next two tiles are just giving you a sense of just how many H3 cells, how many XYZ tiles there are at these different zoom levels. Obviously, like you get into 0 to 14, they almost barely register on this. It's like for the typical use cases, especially for what we might be visualizing in Omni, you're not going to go much past that. So the whole reason that I reached out to Ariel is I had watched the demo about Rob. Shout out to you, Rob, on some questions that had come up around like the file size differences between some of these different formats. So this is a comparison of the U.S. counties in GeoJSON versus TopoJSON, and then in vector tiles as a protobuf. So a couple things to point out with GeoJSON. The one that I'm doing is actually rounding all the lat long coordinates to 6 decimal places. So you could see in this Omni dashboard, right? That's equivalent to roughly 10 centimeters of precision. You literally are not going to tell the difference. The problem though is like, and you might see this with some of your customers, when they just use something that spits off GeoJSON, it's going to go to 9, it's going to go to 12, and that's going to inflate the file size of what they're trying to load in like a BI report potentially. And, obviously some are going out even further, and you can see it's going to reduce the size a lot. So this one is actually, comparing the United States in GeoJSON compared to the others is still 6.6 meg. TopoJSON. So what is TopoJSON? I don't know how many of you are familiar with that, but basically TopoJSON is when there are instances, like I try to put a little anecdotal piece here, where there's redundancy. So in TopoJSON, it doesn't represent the same border twice. So if you have a state boundary, a county boundary, and it's in that file, more than once, it just represents the boundary one time, which is one of the main reasons that it can be up to 80% smaller than GeoJSON. I'm fairly certain that this is like what Looker, heavily uses with TopoJSON. It's also one of the least found out there sources. You could easily convert to it back and forth, but if you're just like looking at easily plug and playing different stuff, like GeoJSON certainly seems like, in my experience, like a more popular format. And then you get into vector tiles. So this is basically like the comparison of the United States, so sort of the equivalent of these other ones, as just kind of looking at what gets loaded in at Zoom 3. I will jump to our platform, which hopefully you can see. This is Zoom 3. So Zoom 3 is basically showing the continental United States. So that's about 1 meg. But what I'll show you too, if you jump into the Mapbox tiling service, is what you're actually seeing at that Zoom 3 is not just the county boundaries. So this is one of the benefits of using vector tiles, is you can have multiple source layers of data inside the same vector tile delivery at the same zoom. So you could turn off all of these, which I will do. you will see that we have uh, the state boundaries. We have, yeah, cool. We have the state boundaries. You have the counties. So we turn off the counties. So there's counties in there. There is the center points of all the counties. So if you want to position the label of the county name at the center point of the county boundary, we've got, we work with farm credit institutions. So there's the farm credit institution boundaries, the state labels, and then also the states. So in that file delivery, right, like you're getting all of this data in one request. So that 1 meg, roughly, or I guess this is 387 kilobytes, is not just counties, it's states, it's the center points, it's farm credit institution boundaries that are custom to our business. So just to kind of couch that, they're just much smaller, right? They're delivered as protobufs. Protobufs are, I'm sure most of you or some of you are familiar with that concept, but Google developed it for serializing structured data. And then the other thing with vector tiles too is at different zoom levels, they actually simplify the polygons to remove points, which they do less of at further end zoom levels. So for instance, like if I'm here, right, like you're not going to actually be able to tell the difference of like that county boundary is exactly where it is along a river or something like that. But as you zoom in, there actually could be doing less simplification. There are more coordinates, so it's more precise when you get further in. The benefit of that as well is like the actual file size when you're further zoomed out is much, much, much smaller. So that's why you get this kind of smooth experience as you're kind of going in and out with these vector tiles. Yeah, and I mentioned like multiple source layers, right? I mentioned that when I jumped to Mapbox Studio. And then the last concept with vector tiles is this concept of over zooming. So I mentioned that you never have to go past zoom 14. Well, when you do go in further, I'm way past zoom 14 at this point, but it still shows the boundaries. So, Mapbox vector tile, it's a vector graphic similar to working with like an SVG where it scales. So the boundary itself like is going to reuse at the zoom levels above 14 the same data that was capped. So it's not making additional network requests, which is why when you're kind of zooming in and you're panning at these far zoom levels, it's going to be a smooth experience on the map. Okay, I took longer than I thought for that first part, but
so interesting. Yeah, and does anybody have any questions? I feel like just getting the background on a lot of how you think about like these different concepts is something that we certainly probably don't have a deep understanding of collectively. This is helpful.
Versus the takeaway here that the vector file is sort of the best one when you can get it. Like that feels like the conclusion based on the talk track.
Yeah, I mean, I think there's definitely some instances where like GeoJSON, for instance, would be easier to work with. Like if you had something that was a much smaller, categorically, the data set was smaller, or maybe like vector tiles is sort of heavy-handed. If you have got a data set that's just small, like you probably don't need to reach for that and reach for the complexity of hosting it and tiling it. So it's not like a one-size-fits-all thing. I do have a gallery, so I've also put together a few Omni dashboards showing some ways that we're going to use it, are using it. So I tried to answer the question just for the purposes of demo. Can you show me the density of owners that own at least 10,000 acres, of which at least 500 acres of that primary use of the parcel is corn or soybean production? So this first map, is just taking the county tiles that are hosted and showing kind of where those owners live. So basically like the address of the primary owner of that land, you can kind of get a sense of like where are, large owners of land collectively in the United States that, some segment of their portfolio is agricultural use. So you get a sense of it, by county. And then with H3s, you're getting a visual here of, again, this is our custom H3 cell vector cell that we're kind of tinkering with now to do some different heat map stuff. H3s, I don't know if you guys have seen this or have familiarity with it. I pulled up a case study, for instance, from Snowflake. This, by the way, is the only geospatial case study that you can find on Snowflake's customer list. So we would love to do something, with you and Snowflake showcasing this, but it seems like it's a popular way to show this kind of like heat map data. So this is at resolution 2. You could see that
do you mind showing us really quick, Chris, if you go to the workbook, just how you've got this configured on our map viz? Because you said this was so this is a custom file that you guys have.
Yeah, sure is. So toggle this off. But basically, so we have taken the data sets that we want to geospatially represent, and we have effectively pre-computed the H3 cell ID. So when you basically are wanting to get the H3 boundary, you could feed it a polygon and you can get a list of H3 cells back. You could feed it a lat long and tell it the resolution that you want. So basically, we have taken our data set that's geospatial in nature and we've pre-computed H3 cell IDs at different resolutions. So our vector tile that's here with this nice interface that Rob has built, you can go back and forth between the different H3 cell resolutions. So we've done 2 through 5, which I'm going to show you in the gallery. And then the cells themselves, there's a string-based variant and then a value-based variant. We chose to basically put both of them in the vector tile. Snowflake has out-of-the-box functions that will do this for you. Uber has a really nice Python SDK where you can generate these. But basically, all I'm doing is like dragging in the dimension at the different resolutions that match what I'm selecting in the vector tile.
Very cool. Cool. Thank you.
Yep. So yeah, the last kind of bit of this is just showing you visually the differences in the resolutions with this data. So again, this is 2 of the same data. This is 3 with the same data, and then go right along to 4. So obviously you're increasingly getting smaller and smaller, and then you're getting down to 5. And then I think this is like a good one to show for the use case of like, it's kind of hard to see it where you would almost like not want to show the boundaries of the data where it doesn't match, because obviously it just looks kind of data overlaid until you zoom in and then it kind of starts to make more sense. Versus like if you look at like this Walt case study, see how there's like nothing in the background except the data that matches. So like that would be like one nitpicky piece of product feedback that might make it kind of present well at a further out zoom. But it just gives you a sense of this. I mean, we have tested with other data. The question that I'm answering with this data set, this is pretty sparse. But we have tested at this resolution and it can seamlessly overlay, 60,000+ different cells on the map, and it's very smooth. So you do get some of that benefit where you could show something that's pretty much across the country. I think that's pretty much all I had to show, except putting in a plug for that access token thing, since I have an audience. When you are building those, like here's ours, this is public, so this isn't like secret, right? If I'm an analyst building one of these, I have to remember where this access token lives every single time to paste it into the vector URL. So that's the only thing that would be nice, to have a simpler variant, and that goes into the doc that I put together. But I mean, other than that, this works really well, and it's pretty easy to use. So some other ideas too that we're thinking about using for this, beyond H3, beyond county, there's all kinds of cool stuff that you can do with, like, for instance, we've got some FEMA vector tiling. So we could show people's portfolios that are in a FEMA disaster zone or a flood hazard zone, and show those on the map using this tool. There's a lot of cool applications that we haven't yet unsurfaced, and we're obviously really just kind of scratching the surface.
This is awesome. And thank you for putting this together, Chris. This is so cool to see. Anybody else have any questions or yeah?
Yeah, sorry it took 18 minutes. I didn't expect to take 18 minutes, but
Oh, you're good.
No, don't worry. That was great.
It's not going to translate well.
Give some real examples.
the short attention span on the internet, it won't transfer well to your YouTube channel. But
Follow
Thanks,
these
Chris.
editorial magic.
Did you build out so those vectors, so your custom like regions and things? Do you build those out? Do you use a service? Like, like if a customer needs something like that, like, and we could help point them to like resources for building their own or?
Yeah, I mean, I have done a lot, and we have done a lot of file manipulation. So, I mean, there's some of that's at play. I mean, honestly, the Mapbox tiling service does make it really, really easy. They do have a boundaries product that, as Rob can attest, it seems like it's very difficult to get access to it. But I mean, if I were you all too, you might consider like expanding your list of stock vector tiles that you would support, since you are using Mapbox. Like, I can help you with that. You know, the H3 cell stuff is pretty easy. The county boundary stuff is pretty easy, but I can, you know, at least help you sort out some of that. We've already done some of the groundwork with which we're happy to share. Yeah, the other thing to mention too is like put this in words, like the H3 cell stuff that I showed you, like I manipulated the global H3 cell set to clip it at the continental United States boundary, for instance. So there's stuff like that that you can do to prune how much money you need to spend pre-processing or hosting the tiles. If you know, for instance, your data is going to be in a specific region, like for us, obviously we're cutting it off at the US boundary. So there's knobs.
Thanks.
Thanks for having me. Yeah, I appreciate it.
Yeah, thanks so much, Chris.
Thanks so much for dropping in.
Yes. Do you, I guess, final thing, we did record it. Are you okay if we do post this in our demos? Is this?
Yeah, have at it.
All right.
First TS demo.
New section.
Yeah. If you're okay with us using it too, if we wanted to. I can't promise anybody at my company will want to.
This is awesome. Cool.